Alright, well, I mean, first we clear out all the old rules so we don't like triple up and get confused. And then these rules grab all incoming packets. So we have ICMP as high priority because that's out of band stuff and whatnot. We have DNS requests, and because we want those to go through really fast.
Yeah.
Then we've got here. Well, here is new connections, and then there's another way of saying new connections, and they get marked as D3 SYNAC. This one here, this is a tricky one. When you're downloading something, you're constantly sending packets that say, yes, I got the data, please send more. So we want those outgoing packets to have a fairly high priority so that we can rate limit on the download side where the bulk of the data is and it gets done properly. So this matches packets that are only small.
Between 0 and 80.
Yeah. The
TCP bytes?
Yep, bytes. So that matches small TCP packets, which are usually just little ACKs or informational messages. This rule matches HTTP connections that have pulled more than half a meg. So, for example, downloads of anything will actually get downgraded to a lower priority. And then there's just regular TCP connections here, such as web pages, most images, JavaScript, the whole bit there. And because it's smaller than half a meg, it'll get a higher priority than any connection that's been running a bit longer. So that's the incoming packets. And then we've got similar stuff down here for outgoing packets. Again, it's ICMP, DNS, new connections get through pretty early. We've got a whole block here for games. I just copy and pasted this port list out of somebody's thing that they posted on the internet. So I don't know if those ports are right or not, but I presume that you might like people to have decent gaming. This is the same connection bytes test for when you're uploading. So when you upload a video, this will kick in at half a meg,
yeah,
and downgrade it. This is some regular expression stuff, which I think I need to move over to the incoming side.
So the initial burst will be quite fast, and then we'll go, drop it down like this one, the long running connection.
Yeah. The first half meg will be quick, and then it'll get downgraded and have to sit in the queue with other downloads.
Yeah.
Which means that your browsing web pages remains fast, even though without this rule, downloads and web pages would be in the same queue.
Yeah.
These are some regular expressions that just match common, large file types, I suppose.
Yeah.
And they should get downgraded to the low HTTP, but I think I'll flip this to the incoming side soon. This one just grabs any HTTP that falls through from up here that doesn't get marked as low for any reason. This is a catch-all for peer-to-peer, and this is where the packet filtering ends. Below here, we set up a couple of queue types, like just quick names to refer to these settings, basically. PCQ is a per connection queue, so each connection has its own slot within the queue, and they get round robin, so that if you've got 50 connections in a queue, then they'll each have equal rate,
yeah,
as long as they're all, as long as both ends are running at the same rate anyway.
So it cycles through a queue.
Yeah.
Basically.
So there's another one here. This red, random early drop, that will actually force the TCP protocol to slow down by dropping packets. And we use the choke on low HTTP and peer-to-peer. I might put it in here as well, actually. These are the actual queues themselves. First we have a parent queue that attaches onto the interface, right? And that grabs all the packets, and it has a max limit.
Yeah.
So that'll be your maximum download rate, and this will be your maximum upload rate here.
Yeah.
And underneath this we have sub queues basically, and as you can see, the parent is set to the name of this one.
Yeah.
So these are actually like leaves of the tree there. So these ones each have a limit rate, and basically the sub queue is guaranteed to receive the limit rate worth of bytes. So if all of these queues are at 100%, they'll all be running at the limit rate.
Okay.
Right? If another queue is empty or running slower, for example, if there's nothing actually in low HTTP downloading, then all the speed that this queue doesn't use can be used by other queues, such as the HTTP or game or DNS or whatever you like. So this is actually a really sensible way of doing things. It's not like we grab all the downloads and limit them all to 100k a second. It's like, well, no, they get 100k a second, but they can run at 1 megasecond if nothing else is going.
Yeah.
So that's what this all does. A lot of it's copy and paste. Like the only thing that really changes here is the name and the priority and the packet mark that we pick up. The packet marks are from all the stuff up here. All right, so we've got one set for downstream that attaches to the local outgoing interface, which is the LAN side. And then we have the upstream, which attaches to the public outgoing interface, the WAN side.
Yeah.
Fin.
Great. Of uploading that script to the router.
Well, it's pretty. Basically, I just run the script, and I can copy and paste all that, and just copy that and just paste it straight in here.
Okay.
Or you can do this and then pipe it to like that. That's another way to do it.
Cool.
But I'm not going to do it now because then it'll wipe out all our counters.
Yeah.